notice we have x plus 6 is less than 8, and then you have that symbol that looks like a V, okay? Most of the time we use words, but every now and again they will switch those words with these symbols. And then you have x minus 9 is greater than 10. So this V is going to represent the word, maybe, or, okay? So think about it like this. Or, like I don't care, or I'll have this one or that one. So that's kind of how I remember which one is which, is just like shrugging my shoulders. So that's the V. So this is saying x plus 6 is less than 8, or x minus 9 is greater than 10. So what we're going to do is we're going to solve each inequality individually, and then we'll talk about how to put them together. So go ahead and solve that first one. X plus 6 is less than 8. And we're going to treat them individually at first. We won't bring them together until we get to our graph. So to solve this, I'm going to subtract my 6 over. So that's going to be x is less than 2. Or, go ahead and solve the second one. X minus 9 is greater than 10. Solve that one for x. We're going to do that by adding our 9 over. And then we get x is greater than 19. So my solution set is x is less than 2 or x is greater than 19. Okay, so the first thing we want to do is set up our number line. Your smaller number always goes on the left. The only two numbers we have to put on this number line are 2 and 19. Which one's smaller? 2. So 2 goes on the left, 19 goes on the right. What or means is I only have to satisfy one of them. I can either be less than 2 or I could be greater than 19, but I don't have to be both. I can be both, but I don't have to be both. So what I do first is I don't actually shade on my number line until I look to see where my solution set is. So I want you to just kind of watch what I'm doing for a minute without writing this down, and then we'll talk about where to shade. So I'm going to start with 2. If I am less than 2, first of all, is that an open or closed circle at 2? Open, okay. And then less than goes which direction? To the left. So what I do is I don't shade first because we could have a special case. I just draw a little arrow above that, kind of pointing in the direction that satisfies that. Less than 2 would be to the left of 2. And then the other inequality says x is greater than 19. Is that going to be open or closed? Open, and greater than is going to go to the right. So again, I'm not going to shade just yet. I'm just going to draw myself a little line pointing in the direction that satisfies. And then what I do is I go to my number line, and I always start on the left side. These lines up here show me where my solution set is for that particular inequality, and we're going to go or. So I only have to have one of them true, but I could have both of them true. So to the left here, is at least one of the inequalities true? Do I have a line representing it's true up there? Yes, so I can shade there. So I'm going to go and shade everything to the left of 2. And then I look at the spot in between. Does this spot in between satisfy at least one of those inequalities, less than 2 or greater than 19? No. How do I know if there's no line above it? That's why I draw the lines above it so I can physically see where they are. So I would not shade in between 2 and 19. Does that make sense? And then I go to the right side. Does this satisfy at least one of my inequalities here? It does. Okay. So I can shade to the right there. So that shading, the gray area, is where I'm representing one or the other. I could have both, but I only have to have one of them true. That's what a normal OR graph should look like. It's not one of our special cases. OR generally is going to go to the outside like that. Okay. Everybody ready to talk about writing the intervals now? We always start on which side? The left. Okay, so we're shaded as far left as we can be, correct? So what numbers does that represent? Negative infinity, And then we go up to, what's the first number we touch? 2. Am I open or closed at 2? Open. So does that mean a parenthesis or a bracket? Parenthesis. So that represents my first solution area. But that is not the only solution area. I have another area that I have to represent as well. So on a graph, when we have 2 separate areas, we're going to have 2 intervals, and we're going to combine them with a U. That means union. Okay, so this one or that one. So we're going to put a little U in between. And then we keep going, and the next place that I have any kind of representation is at what number? 19. Am I open or closed at 19? Open, so that's a parenthesis. And then I shade as far to the right as I can, which takes me to positive infinity, and then that's a parenthesis. So my final answer should look like that. So if it's a normal or graph, you're going to have 2 solution areas, and you're going to write the interval for each and combine them with a little U in between. All right. Take a minute and write that one down. And there's a, I don't know if y'all can see that very well. I'll darken it. It's an upside down V. Two x plus 1 is less than 9. And you got that upside down V, and then you've got x over 2 minus 1 is greater than negative 6. So if the V meant or, what do you think the upside down V means? And, yes. Whoa. That did not work like I needed it to. Try that one more time. So that means and. What and means is both of the inequalities have to be true at the same time. Okay? Think about it as and. I'm holding on to both of them, the upside down V. I want them both at the same time. I want to go to dinner and I want to go to a movie. Okay? Or I don't care. It's one or the other. But and we have to have both. We're still going to solve each inequality individually. So start with that 2x plus 1 is less than 9 and solve it, please. Once you get that one solved, you can solve the next one. X over 2 minus 1 is greater than 6. And then once we get each one solved, we'll take a look at the graph and what that should look like as a normal and graph. And I keep saying normal because we will have cases where we don't have normal ands and don't have normal ors, and we have to be very careful as to what shaded regions are represented. So I'm going to start by subtracting my 1 over, divide 4. So x is less than 4. That's the first one. And also, if you don't like the symbols and you want to write the words, be my guest. I don't care. Okay, sometimes I'll put the symbols, sometimes I'll put the words. You just need to make sure you know the difference between the two. And then for the next one, I'm going to add 1 first. Some of you might have multiplied first, and that would be perfectly fine. I'm just going to try to make it a little easier. Negative 6 plus 1 is what? Negative 5. How do I get rid of that 2? Multiply. Yeah. So just multiply both sides by 2. So I have x is less than 4 and x is greater than negative 10. So once we get each one solved, we're going to go to the number line again. Remember, the smallest number goes on the left. What's smaller, 4 or negative 10? Negative 10. Okay. And again, before I actually shade my solution on the number line, I'm going to draw my arrows above that so that I can see where they are true, and then I can go from there. Starting with x is less than 4. Is that open or closed? Open. And less than goes which direction? To the left, right? Less than is left. So you'll notice above my number line, I'm drawing a line to the left. And then if x is greater than 10, that is going to be open, and greater than goes which direction? To the right. And then I have to keep in my brain what I'm looking for. Am I looking for and, or am I looking for or? This case is and. Starting on the left, do I have a solution represented for both of my inequalities here? No, my red and blue lines are not both there, only the blue line is, so that doesn't satisfy both of them, so I cannot shade there. In between negative 10 and 4, are both of my solution sets represented there? Yes, that's where my red and blue lines are, so I can shade everywhere between negative 10 and 4. And then I go to the right side. Do I have both of my solution sets represented here? No, so I would not shade there either. So the only place I can shade for an and graph that's normal is the intersection. Where do they overlap? Where am I greater than negative 10 and less than 4? So then we need to write our intervals. How many intervals do we have? How many shaded regions? One. Just one. So I'm just going to have one interval. Again, we're going to start at the very left of our number line. Am I shaded to negative infinity? No. Where am I first starting my shading? Okay, and it's not equal to, so we're going to put a parenthesis. And then I shade up to what number? 4. And again, not equal to. So that is going to represent the solution set for that compound inequality.
So, like cases like this, when they're intersecting,
it depends on if it's and or. Okay. If it's and, yes. If that happens to be or, in a different situation. Everybody okay with that? All right, go ahead and start number 3. Go ahead and solve each inequality. Is that one an and or an or? Or, okay. Go ahead and set up your number line, and let's take a look. And yes, you can have decimals here, or fractions, however you want to leave them. Solve each inequality. And go to your number line. Remember, the smaller number goes on the left always. The larger number goes on the right. And then take each one separately to see where there's if you end up with a fraction, just make sure you know the value of that fraction so that you can compare it to the other number. Sometimes it's easier for people to turn those fractions into decimals to be able to take that comparison. That is just what you're comfortable with or not. And we need to make sure that our smaller number goes on the left, our larger number goes on the right. So we need to know which one is smaller and which one is larger. If you're not good with fractions and being able to tell their value, go ahead and divide them out and turn it to a decimal, and that will make it easier. I don't care if you leave your answer as a fraction or a decimal. So I end up with x is greater than or equal to 11 over 2 or x is less than 4. But before I go to my number line, I need to make sure I realize which one is the smaller number. So if you aren't sure, do 11 divided by 2. That would turn into what decimal? 5.5. Okay, so then it might make it a little bit easier for you to tell which one is the smaller number as a decimal rather than a fraction. What's smaller, 5.5 or 4? 4. So that goes on my left. 5.5 or 11 over 2, however you want to leave it. It doesn't matter to me. So starting with the first one, if x is greater than or equal to 5.5, I'm going to shade that circle in, and greater than goes which direction? To the right. And then x is less than 4, that is open, and that goes to the left. And again, this is an OR graph, so I only have to have one of them true, but I could have both of them true. Are they true to the left of 4? Or is at least one of them true to the left of 4? Yes. Okay, so I'm going to shade there. What about in the middle? Is at least one of them true in the middle? No, so I would not shade there. And then what about to the right of 5.5? Is at least one of them true there? Yeah. Okay, so we're going to shade there as well. Okay, a normal OR graph. We have two different shaded regions, so we need to write our intervals for both. I start to the far left. What is that going to be? Negative infinity all the way to 4, parenthesis or bracket? Parenthesis. Don't forget to put your little u in between. And then I pick back up at 5.5. Is that going to be a parenthesis or bracket? Bracket. And again, you can leave it as 11 over 2 is fine with me. And then that shades all the way to the right, which takes me to infinity. So that would be my final solution set. Anybody have any questions so far? You guys remember doing these? Somewhat? Oh, no? Okay. All right. I want you to solve each one individually. Go to your number line, draw your lines, and then just stop. Like draw your lines above because we need to talk about this one. Solve each individual each inequality individually, if I can talk today. Then go to your number line, make sure you know what that symbol represents. And then just hold tight because we want to talk about this one. This is one of our special cases. Keep in mind what that symbol represents. The upside down B means and. That means they both have to be true at the same time. And that is the only area where we can shade. Solving the first one, by dividing by 2, I get x is greater than 1. And x is greater than negative 4. What's the smaller number? Negative 4. Okay. So starting with the first one, x is greater than 1. That is open and going which way? To the right. And then x is greater than 4. That is open and also going which direction? To the right. That's not what the normal AND graph looks like, is it? with the normal and graph, they were both going in. So starting at the left, do I satisfy both of my inequalities here?
No.
No. Do I satisfy both of them here? No. I satisfy one, but not both. And means I have to have both. Do I satisfy both of them here? Yes. So I can only shade to the right of one, which is not the way a normal and graph looks. Remember, the normal and graph is usually shaded in the middle. So this answer is also going to look a little different based off of the shading that we have. This is why I said you can't say your answer until you go to the graph, because you can't always tell what the solution set is. Just because it's and doesn't mean they're going to be crossing over and shading in the middle. So to write my interval from here, what is the first part that's represented? Okay. We don't have double shading here, do we? That's not equal to, right? So that's open still. We don't have double shading here, so we don't start double shading until 1. Am I equal to 1 or not equal to? Not equal to. So we're going to write our parenthesis 1, and then we shade forever to the right, which takes me to infinity. So the only place where they are both true is everything greater than 1. So that's the way my answer is going to have to look. Does that make just a little bit of sense? Okay, go ahead and start with 5. This is going to be another special case. This is an OR special case. We have a couple of different types of special cases that we run across. Which means I only have to have one inequality true, but I could also have them both true. Like if I said I wanted new shoes or a new shirt, would I be okay if I got both new shoes and a new shirt? Of course. But I just said or, so I would be happy with one or the other, but I would also be happy with both. Go to your number line. You can go ahead and draw the lines above it. If you're not comfortable to finish the shading, you can hold tight. It looks like everybody's lines are in the correct direction. Take your neat to draw the final shading. If I add my 6 here, x is less than 8, or subtract my 2 here, x is less than 16. What's smaller? 8. Also, if you don't put your numbers in the right spot, that will completely mess up your answer too. Less than 8 is open and going to the left. Less than 16 is also open and going to the left. Remember what we said, or. One or the other, but I would also be happy with both. Do I have at least one of my answers in this area?
Yes.
Yes. So can we shade here?
Yes.
Yes. So go ahead and shade there. Do I have at least one of my answers represented here? Yes. So we can shade here as well. Do we have at least one of our answers represented here? No, so I cannot shade there. So basically, we can shade to the left of 8. We can also shade to the left of 16. Should I cover up the 8 and make it a closed circle? Yeah, 8 is less than 16, isn't it? So it satisfies at least one, so we will go ahead and shade right through that to make it closed in there. Remember, I only have to satisfy one of them. 8 is not less than 8, but 8 is less than 16, so I can shade that in as a solution set. And now we're going to write our final answer based off of what is shaded, and we have everything to the left of what number? 16, so we're going to start at the left. What's the first number shaded? Negative infinity, and then we go all the way to 16, parenthesis or bracket? Parenthesis. Okay. So, or, if you look back, looks a little different than and in some of these special cases. In both of these questions, the arrows were going in the same direction, but where we shaded was different based off of the word. And means they both have to be true at the same time. Or means I only have to have one of them true. Does everybody understand the difference between? Okay. All right, write down number 6. We're going to talk about this one. For some reason, this one tends to confuse people. Six is less than x plus 4 is less than or equal to 12. Sometimes they write inequalities combined together as one like this. These types will never be a special case, and they are always going to be an and graph. Because what this is saying is that the stuff in the middle, the x plus 4, has two different inequalities with it. 6 is less than x plus 4, and x plus 4 is less than or equal to 12. Does that make a little bit of sense? So that x has both. We have two inequalities. Also, anytime they write it as a combined inequality like this, it should always be less than symbols. It should never be a greater than in there, otherwise they're trying to confuse you, okay? Because we're always starting with our smaller number, has to be less than the middle term, has to be less than the larger term. We can separate this out, but it's usually easiest if we just leave it as it is. I want to end up with x in the middle all by itself. What's next to x right now? The 4. I'm going to get rid of it by subtracting since it's a positive. And if I subtract in the middle, I also have to make sure I subtract on both ends. Okay, so I'm going to have to subtract it from the 6 and also from the 12. So we have 3 different areas here that we're going to have to subtract it from. The goal is to end up with that variable in the middle all by itself. Again, this is always going to be a normal and graph when it's written together like this, so we have to think about that. 6 minus 4 is 2, is less than x, is less than or equal to 8. Smaller number always has to be on the left, which it is. And then when I go to my number line, we don't really have to think too much about this. I'm going to put the 2 and the 8. Am I open or closed at 2?
Open.
Open. Am I open or closed at 8? Closed. And then where is x?
In the middle.
It's in the middle, so guess where I should shade? In the middle. Okay, those aren't anything to have to think about other than getting that x all by itself in the middle. I don't tend to give too many of these, but I might give 1 or 2. Okay, for some reason they confuse us. And then to write my interval, parenthesis or bracket to start. And then I go from 2 to 8, and then I put a bracket. Okay. So those, don't make those more difficult than they are, please. Just solve getting the variable in the middle, smallest number on the left, smallest or biggest number on the right, and we're going to shade in between there. All right, I want you to try 7. This is another special case. I want to see if you can figure it out. Hey, hold on, I'm just looking. Yeah, okay. I knew we were getting close. Whoops, sorry. There you go. So once you get to the middle, think about what center one is, what that means. Draw your arrows above it. And then think about where the tree should be. Did everybody get x is greater than 4 or x is less than 10? 4 is the smaller number, so it goes on the left. All right, greater than 4 is open and going to the right. Less than 10 is open and going to the left. Remember, the word is or, so I only have to have one of them true. So starting at the left side, do I have at least one of my inequalities through here?
Yeah.
So shake there. Then in the middle, do I have at least one of my inequalities through there?
Yeah.
Yeah, so we can shake there. And then to the right, do I have at least one of them through there?
Yeah.
Yes, so we can shade there as well. So I'm going to shade, and I'm going to shade, and I'm going to shade. Now, one question before I go to my answer. Can I close in 4? Is 4 either greater than 4 or less than 10? Yes, so I can close that in. Can I close in 10? Yes. So basically, what do we have shaded? The whole thing, which means all of the numbers on the number line are going to work, which we would normally say all real numbers, right? But in interval notation, we're going to write it a little differently. How far am I shaded to the left? To negative infinity, and I go all the way to positive infinity. That's how you write all real numbers with interval notation. Negative infinity to positive infinity. Everybody okay with that one? All right, I got one more. It's at the bottom there if you want to go ahead and get started on it. And you'll notice I switched it to the word instead of the symbol. I will do that. I will put symbols sometimes. I will put words other times. So we want to go ahead and work on number 8. Four means only one. Means I solve both of these. I get x is less than 4. And x is greater than 10. 4 is my smaller number. Less than 4 is open and going to the left. Greater than 10 is open and going to the right. What word do I join them with? And. That means they both have to be true at the same time. Are they both true here to the left? Are they both true in the middle? Are they both true to the right? So if I cannot shade anywhere, that means I don't have any answers. So what do we write? No solution. Okay. So a key to remembering some of the special cases, if your lines are crossing over each other, going in the middle, and the word is or, that's going to be your all real number special set. And then if it's and, but your lines are going out, that's your no solution special set. Does that make a little bit of sense? All right, that worksheet I gave you is your homework.